you guys left off yesterday,
The only thing we addressed yesterday, I think, is that question 1, really, that's on the page. Why is 3 added to both sides? That's the only thing we talked about. And it was literally just briefly, like I don't know if they had time to write it down.
okay, so we can start off with that. So looking at this work example, this idea of factoring quadratic equations, it says we use factoring to calculate the roots, right? So isn't that what we were doing when we were graphing it to find the roots? And then we can write in factor form. So this number 1 asks us, why is 3 added to both sides in the first step? So I want you guys to look from here to here. Why are they adding 3 on that side?
Create 0.
What do we need to create a 0 for? And what tells us that we need to create a 0 so we can find those roots? So remember, finding roots, or what does the 0 product property tell us?
At least one had this.
Right, so if we know, like if we have an equation that's set equal to 0, we know that either one of those factors has to be 0. So, Mr. King, do you want us to write for this one?
I mean, it wouldn't be a bad idea.
Okay.
Yeah. Yeah. You could, yeah, why is 3 added to both sides? When we factor, we want to be able to use what property? You just said it.
I'll write it up here so y'all can
Yeah.
see it a little bit better.
Yeah.
But, so, right, key. Do you want to say like keep the equation balanced?
Well, that's
It
just
says why do we add 3 to both sides?
I get, yeah,
is
I
the
mean, that'd be part of
question.
it. The bigger reason of just adding 3 is so we can use the
Right.
0 product property, and then we have to use the property equality. Yeah.
Right.
That's a good point.
So I was just, okay, so we said, we'll note that we're keeping the equation balanced. So that we can use the 0 product property to find zeros for the equation balance. So like 3 equals 0 property. Should we say find solutions? Would that be more?
We can use the 0 product property to find solutions, zeros. Let's do, yeah, solutions to the equation. Yeah, I think that's.
So it's this idea of we're using like quadratic formula, like the roots, everything we've been talking about previously. Now we're kind of thinking of these zeros as solutions to that equation, because what does a solution do to an equation?
Makes it true.
Okay, so it makes it true. So that means that once I find my zeros, if I substitute them back in, what should that be equal to? Yeah, it would be equal to, in this one, yes, but then whatever it's equal to. Oh, and find solutions. But so kind of just as we're going through this learning about factoring, we're doing this as like for factoring to find solutions to the equation. Can you put the next one? Okay. Look at number 2. It asks us to determine each student's error and then solve the equation correctly. So I want you guys to talk in your groups for about a minute or so, look at both Angela and Dwight, and ask yourself, did they find the correct solutions? If not, what did they do wrong, and how can we fix it? Okay, so maybe a good idea to reference that worked example we just looked through. Read some of those things on the sides, telling you a lot of good stuff. So, and I'm coming around, so take a few seconds from the groups, and we'll come back up here.
Basically, she just split up them X's. Well, I need to see that second X.
What up? So,
I think you see that.
what did we just talk about number one? What did we have to do? What did number one ask us about?
So she would distribute it.
Why 3 added to both sides in the first step?
Okay, so why did we add 3 to both sides?
Let me try it.
Okay, so get a 0. Does Angela have a 0?
No,
So what does she need to do?
create a 0.
So did she do that right? Okay, so what is she, how is she going to create a 0 to look at that work example? How did we just, or how was that 0 created? Yes. Where? So that's 7.
X squared is. That's the same.
Well, it tells us she's wrong. Because it wants us to find the error, so it's just saying, you already know she's wrong, tell us what it is.
So we gotta find hers.
Well, it's telling you she's wrong, because it just says find her error.
That's why she's wrong.
Okay, let me tell y'all this. What did we just say we have to do with number 1? Why did they add 3 to both sides?
Because she wanted.
For what?
Get a zero.
0.
Because we're looking for those zeros. Is that what Angela did? Okay, so what would Angela need to do? Right, she would have to create that 0 by first adding 7 to both sides. Oh, sorry, subtract 7 from both sides, right?
Oh, true.
Yeah, subtract 7 from both sides, creating 0. Okay, so then how can I rewrite this side of the equation?
A squared plus 6x minus 7 equals 0.
Okay, so now from here, can I factor this quadratic equation?
Yes.
What do I need to look for to factor it?
You gotta use that
AC method, what's that, Chloe?
Define factors of A and C that add up to B.
Okay, we're looking for factors of A and C that add up to B. Okay, Preston, tell me what that means in terms of this problem. Factors of A and C, so I'm looking for factors of what number? Of A and C, what operation are we using with A and C? Okay, we're multiplying A and C. So when we multiply from here, A times C, what do I get? Okay, so we're looking for factors of -7 that add up to what?
6. 6.
Yes. Okay, so y'all take a second, work that one out. We're looking for factors of -7 that add to +6.
That's only
Talk in your groups. Okay, because then because after you get your factors, write it in factor, or, like I said, you don't need to write it. I'm just looking for the,
Okay.
We make them own little things.
Is that what y'all got?
They keep
No, you did
What?
right.
I ain't
She right, she right.
So factors,
No.
what do we mean by factors? What are factors of negatives, or what are factors of 7?
Get 2 answers.
1 to 7.
Okay, so what combination of 1 and 7 can I create that's gonna add to 6?
That's what we get.
So we said x,
7 minus 1 is 6.
7,
Okay.
is this what you wrote, Tyrese?
Yeah.
Okay, can you check yourself on this?
Yes.
How?
Right.
Okay, I could graph that and, right, I could do that. How can I check this algebraically?
Distribute.
I could distribute because once I multiply all this back out, what's it supposed to look like?
X squared plus 6x minus 7.
Right, because what we're doing here is we're factoring this quadratic equation because this is the standard form and this is the factored form. Remember, those are the same things because if I graph the standard and graph the factored, it's going to be the exact same shape on the graph. So now I'm looking for values. That's why we're using that AC method to look for those values that like meet those requirements. Okay, so did y'all talk about the grouping yesterday? Y'all did do okay.
Yes,
So
that's the primary way I teach it.
okay, so I did
I might just focus on the practice problems on the TI
the
side.
poll. Okay, yeah,
Yeah,
that's fine.
because the focus there is just to recognize that they're not, the equations aren't equal to 0.
Yeah.
Did you talk about that already? Or did I just read it? Okay,
No, we didn't.
okay. Sorry, I was right.
Okay, so we're gonna practice before we start. Notice how the next page asks solve these equations. Before we start solving, we're just gonna straight up practice some factoring. Okay, so that idea of finding the greatest common factor and pulling it out and figuring out what we have to multiply in. So wait, do I need to? Did y'all get some of the calculators?
I want to write it on the cell. I'm going to write it on the Excel.
One more thing.
Don't mind,
Mine.
Okay, do y'all have this on your calculator? Sorry. Okay, so just focusing on factoring. Oh, sorry, let me make this screen bigger.
You gotta be made out of it. See what else. I mean, wood.
AC method. Which doesn't have a C.
Okay, so we're gonna start sending out these poll questions. We can only do one at a time. So this is our first one. We got to factor 3x squared plus 15x. Okay, so what things do I need to look for in this expression? Well, not zeros yet because it's not equal to 0. We'll get there. We'll go back to that idea of solutions. But what's up? Okay, factoring. So what am I looking for when I'm factoring? Just not equaling it to 0.
AC method.
GCF.
Looking for the GCF?
The greatest common factor.
Okay, the greatest common factor. What is that? Sorry, not, what does it mean, the greatest common factor?
The greatest number that come.
Okay, the greatest value that goes into both of these terms, or if it was like a trinomial, or it had more terms, then that greatest common factor would have to be common in every term. Okay, so,
Is it 5? 3 and 15?
okay, now this is where you do in your groups, and you work it, and I'm coming around, we'll talk, and we'll come back. Factor.
He just shouting out stuff at you.
So, KT, why did you say
Because it's the
5?
greatest common factor.
Or why did you think 5?
'Cause 3 and 15.
Okay, so is 5 a common factor of 3?
No, I think it's 1. And 3?
Is 3 a common factor of 3 and 15?
Make a point.
Yeah.
Is it the biggest one?
Yes, it should.
Okay, okay, that's the greatest. Yes. Is there anything else in common between
That's the least common.
term 1 and term 2? The two terms that I can factor out.
No.
Now, which one?
So we just said the 3 is a common, right? Well, what else is common? No, oh, sorry. I meant between, like, on the,
It's not.
That's
It's not that you can divide those by.
okay, so we just said we can take out the 3, right? Is there anything else common I can take out of those
No,
two?
look, we got distributed.
Literally the number.
Okay.
Oh, we don't equal it.
Because I have an X here. Okay, so that's a great question. So by taking it, I'm factoring it out because when I multiply it back in, it should equal 3x squared. So 3x times what is going to give me that 3x
X
squared?
plus 5. And X minus 0.
Okay? You see that?
So only option is
Okay? And then 3x times what gives me 15x?
Because I had it then.
5.
Right. And notice it already has an x here.
No, I should have read
Well,
Yeah, that's
when am I going to get that square? When is that square going to come back?
Oh, I'll get this rest.
When I multiply them together. So when it's in, which, this isn't, these aren't equations, but if we were to set these equal to 0, remember this is the standard form and this is a factor form. So remember the same thing is written differently. So this would be your answer. If it says, write this in factored form, this is what it's asking, this is what it's asking.
My calculator off one more time.
Okay, so what is in common, because we were talking about that idea of GCF, right? So what's a common factor I can pull out from both of these? So by a common factor, it needs to be the same thing. What's the factor that goes into 3 and that also goes into 15? Okay, well, just 3. Well, yeah, I mean, both of those do, but the biggest one is 3, right? So by factoring, remember,
It was an eraser. It's okay.
because remember, so we're factoring, we're like working backwards. Okay, so you said is there anything else in common between these two terms? Okay, so remember when I'm factoring, if I were to multiply it back out through distributive property, I would get this. Okay, so if I pull out my greatest common factor, what needs to go here so that when I multiply, I'm going to get this again?
X plus 5.
Y'all talk about it. Huh? It's not letting y'all type? Oh, I'm sorry. Y'all can type?
3 times 5. Minus 5.
Should be.
Because
I don't Any of y'all?
Okay. Well, nobody, they've been,
I'm literally out of it.
Wait, so what's your issue about typing?
it wasn't her. It was,
Oh.
not her.
Oh.
But I don't think it's showing up on here.
Once you type it out, go to submit poll at the top left. Yeah, top left, there's an option that says, it says quick poll. Click on that, and that will give you an option to submit the poll question.
So you telling me all of them that we need
Oh, multiply, imply. You need to put, hey guys, if you type 3x and then parentheses, you have to put a multiplication symbol between the x and the parentheses. That's
You
the
got
issue.
3, so
Mr. King.
Give it. Hold on 1 second. Check to see if it works now. So go quick poll. Okay. So it wouldn't accept.
no. So we're just
Yeah.
we're not solving it. We're not making an equation out of it. We're just pulling out the DCF.
After it was
So like you said, the DCF
You don't have to.
is 3
That guarantees that it shows up there as soon as you
Right.
work.
Okay, so remember I'm making some stuff in common. What's common between these two terms? Okay, so when I'm factoring, remember, I think Mr. Candace might be also why third block is confused, is that,
First.
yes, first block is by the idea like we're factoring, we're just reversing the distributive property process that we've worked on, but we're not like creating anything new from that.
So.
Like I think you guys are trying to make it harder than it is. Like I just think that was confusing the first block maybe.
So I guess in that vein, what mathematical operation are you using with distribution? Multiplication. So when you're factoring, what operation are you using? You're dividing to factor it out, right?
Okay, so the way so I'm gonna write it big up here. Okay, so we've talked about this idea of greatest common factor, okay? I know all of our groups have figured that out. What's our greatest common factor in this expression?
3x.
Okay, 3x. Because remember, I'm looking, what's the biggest thing I can multiply into both of these that allows me to put it on the outside? Because that's what I'm multiplying, which we'll see that when we multiply. Okay, so now 3x times what is going to give me a 3x squared? Okay? So then, what's my next term going to be?
Plus 5.
Okay, so where's that plus 5 coming from?
50.
Because what are we doing? Okay, and then so when we say factor, this is what we mean. Like this is it. This is the factored form of this expression. If it was set equal to 0, it would be the factored form of that equation. Does that make sense? So then from here, you don't have to create a new equation. You don't have to go back and like add anything to the end of this. We're just factoring that. Okay, so I'm going to go ahead and send out the next one.
Alright, I got this.
Wait, can we just do another one? Can you create another one like that? When we're doing on the AC method. I think in first block they were like, we did this, and then they were like, you did this.
So to create one is on the block. You can just do this, create a quick poll. So.
I look like
I love my AirPods.
That's not.
They work well. I'm on my third. I got this. This is my first pair of AirPods. But the other ones.
Okay, guys, we just sent out another one. Go ahead and tackle this one with your groups. So we're factoring this expression. Okay, so remember about factoring, it just means if I were to distribute, when I'm done, I'm getting what I originally had. We're just working backwards. But this is equivalent to this.
3, 7. Oh, yeah,
3x.
3x.
I gotta find another greatest common factor.
That's right. So what am I looking for, KT?
I'm gonna just guess.
So what, 2x right here?
Is it confusing you if I still have this one up too?
2x.
Minus.
Is it 3x again?
No, it says 3X.
Oh, you need 3? Oh, yeah.
There's a way you can check yourself with this stuff.
I was just guessing.
So 3 times 2.
What's up?
Squared and 3 times 7.
We got it.
And you multiply it back out and you get.
Done.
But out loud. I ain't doing no else. Okay.
Hey, let me ask you this. So remember, whatever we pull out on the outside has to go into both. Everything on the inside. Can 6 go into 21? So can I pull out a 6? No, I should look for something else that's common in both.
That is such heartbreak, though. Like, I'm sorry.
Okay, so have y'all found like the greatest common factor? Okay, so now here we go.
They could have given nobody. Like, the one who just like, right.
What's right?
Yeah.
He's cute too. Bruh.
That's all it goes on.
Yeah, 20 had it, yeah, but you were just having to put an X there, and then you take the square off.
I'm sorry. She don't hear, like, where are you?
So it's 7.
Remember when I multiply it back out, it has to equal this.
I need to start a
So
chart.
what I'm trying to get was, we're not even multiplying it, it's 6x squared.
Literally. I need to start charting mine back up. It's in
Well, that's not even 3x squared. How do I make it 6x squared?
no, you either was no, we were.
I see what you're saying.
2x, because that's what we're remember, it's gonna look like 6x squared minus 21x.
Yeah.
And then what do you multiply 3x times by to make it equal? What? Wait. What are you doing?
He's telling you I did yesterday.
I just learned it today.
Wait, me or
Stop! No. Did you? I'm a
How did you get, where did that 3x start?
I do.
Man, bro.
Yeah, because I'm gonna multiply it back out, I'm supposed to get this. This is what I was gonna try to check over. Because I know, is that how you guess it?
So you're saying you're right.
Okay, so remember,
If you don't explain, we just need you to collaborate with it next time.
There was like almost fighting my neighbor.
Talk about
I was walking in the rain, bro.
Since you satisfied.
yes, you did it.
Oh.
I didn't know what it was. I was walking around like 2:30.
Okay, so remember, we're multiplying it back in. So to get to the 6x squared, we're going to multiply by 3x.
I'm like, bro, what y'all doing? And then they were like, wow, you have a brain. I'm like, what was going on?
Wow.
But
They're right.
you said it was wrong.
He didn't say x plus 2, what did he say multiply?
This
Because
one.
we're trying to equal.
3x squared.
I'm trying to equal 6x squared. We're multiplying by 3x squared. Minus because why?
I was about to ask him.
I know she was trying to.
Y'all locked in, man.
Yeah, Ashley's on the right.
Alright guys, let's go over this one real quick. Xavier. Y'all, Xavier did this one right. He just can't explain why, so we're gonna figure it out. You said that it's 3, right? Tell me what you got. 3x, 2x.
Yeah. 2 minus 2.
Okay. Okay, and his group was like, where is this coming from? Because they understand how we can multiply this back out, and it's supposed to equal 6x squared minus 21x, but Xavier, why is this 3x out in the front?
GCF.
Okay, how do you know that's a GCF? Does 3 go into 6? Does 3 go into 21? Is that the biggest factor between both of those numbers? Okay, something I will point out is I saw some people trying to put a 6 in the front. Well, does 6 go into 21? So we know we can't use 6. Okay, so then from there, we pulled out that 3x, our greatest common factor. We have to work our way back in. So how did you get the 2x minus 7 on the inside of parentheses? So remember, when we pull out a 3x, my first term that I multiplied has to equal what? 6x squared. Okay, so I'm like, 3x times what gives me that? 2x. And then where's that negative 7 come from?
21 times 3 times 7 equals 21.
Right, that 3x times negative 7 gives me negative 21x. So this is how we write it in factored form. Okay, so also make note that the GCF is not always going to be just whatever that first number is. Because this one wasn't 6 because it doesn't go into 21. So you have to look at both of the factors. Okay, so now let's do, going into, okay, so this one, what method do we need to use here, guys?
AC.
AC method. Okay, so remind me, what does that mean?
A times C.
Uh-huh.
Add.
What do we mean to get?
You need to
Adds to get B. So the product of A and C sum to B.
6 and 4.
Okay, so y'all work in your groups? And
Wait, huh?
In the AC, you gotta do some of this to get this.
so AC method we talked about yesterday. Oh, Mr. Kenny said, like right here, you can copy it from there. But when it's talking about A, B, and C, it's referring to the quadratic equation.
Bro, because you don't be saying it right, then I'll be like,
I just said 6 and 4.
I guess you just, I don't know. Okay, so
Talk
how
about a mathematician.
So can you write that in factored form? How